I got a question on LinkedIn the other day. The question is, in octave analysis or CPB analysis, why is the overall A-weighted sound pressure level always greater than any individual octave? Yeah, let's take a look at that. It's a good question. Here we have, for instance, octave and third octave bands. It's can be described in a similar way because you can divide, just like you would do on a piano, you can divide it into octaves and third octaves. You can divide a sound into different frequency bands like this. And when you do that, you can, when you look at this first octave band, let's see, where do we have, oh sorry, there we have it, yeah. This first one is perhaps 82, and you can go from third octave bands and convert it to octave bands by adding logarithmic addition of these sound pressure levels, 75 and 77, 76. And when you add them together, you're going to end up with this one. And you can keep going. So if you take these three, you add them up, you will end up with this one. You take these three, you add them up, these three add, and you can move throughout the whole spectrum. So if you have your third octave data, you can always convert it to octave bands. You can't do it the other way around. You cannot divide an octave band into the 3 octaves because then the information is lost if you measure it that way. And the same thing would go, now if you would take the weighted sound pressure level on this whole spectrum. I just did a rough calculation to try to see what it's like. So, and I get it, so it's probably around 100 dB weighted sound pressure level here. And you would get that if you made a logarithmic addition of each of these octave bands, one after the other, and you sum them up, and then you would probably end up around 100. And you see that individual bands must always be lower than the one that is higher up in the hierarchy. So in this case, the octave band values, the individual octave bands must always be higher than the 3 third octave bands, of which it consists of these 3 octaves. And when you add these 3 together, the end result must be greater, because if you take 3 of something, you sum them, then the end result must come out on top on any of the individuals in that group. But however, if you have, since it's logarithmic addition, like in this case, here's a good one. One of the 3 octave bands, one of the 3 third octave bands, sorry about that, is a lot higher than the other 2, and that means when you add them together, this one will dominate. So you see the final result here isn't that much of a difference. It's this one dominates, and these 2, they give a slight boost, but it's just a little bit to push it a bit higher here. And the same goes when you go from octave bands into weighted, where you just have one number for all the frequencies. If you have, like in this case, this peak up here, this one will dominate. So it's a strange scale here, but 95, 6, 97, 98 something on this individual one. But when you add all the other black dots up here, when you add them all, you're gonna end up somewhere around 100, which is a little bit larger than this one. However, if the spectrum would be more flat, then you would see a greater difference between the weighted sound pressure level and the individual parts, because then the boost will become larger. It's when the difference between the different octave band levels, when it's, there's a rule of thumb, we could say that if the difference is more than 10 dB, the quieter one will be almost or completely negligible. Negligible. That's a hard word to say. Very difficult. But I think I think you get my point. So that's the reason, Salman Paddle. Thanks for asking. That's a good one. And it's a good one if you have some questions, drop them in the comments or send them to me in a message, because it's good inspiration for my future videos, which will come out every workday at least on LinkedIn. And in today's video, I'm wearing a dark purple, more burgundy violet-ish. It's the camera doesn't really capture it, but this is a full suit with a gray shirt. Gray and burgundy purple goes great together. And with it, I've paired it with a little splash of orange and dark blue and blue here. And I'm going to show you here the details. Now it's time, a little bit of product placement as well. I got these coffee mugs from Norsonic, which also happen to be orange and dark blue. So they go great together with my little pocket square here. And small details like this can make a huge difference on the subconscious when you present yourself. So another thing like the watch, silver, metal, and dark brown leather, and I have the same here on my belt. It comes once again with dark brown leather and silver metal polish. So you have this. It's like the hook of a great song. You have like this little melody that comes back every once in a while to remind you of it. And you can do the same thing with men's fashion. If you have a little hook here and it comes back on the belt, and of course with the shoes, I don't have them in here right now, but then I have shoes with the same leather, and also the little metal things where you put the shoelaces through should also have silver metal on the rings, so they match the belt and the watch, and stuff like that. It matters. It makes a big difference. See you there.